a second. And I'll have my live here in Discord in just a sec. All right, should have that now. Okay, let's see. I think I promised that we would finish this module in 20 minutes. Did I not? I think I did. And that doesn't start that timer doesn't start until I start, okay? Because I also need to drop the link in for everybody. I think I did. All right, there we go. Okay, boom, there's the link for the live, for the YouTube stream. That normally blows up. It's not looking like it's blowing up for me for some reason, but it should. Okay. But it's there anyway. I boldly entitled this thing Module 6, but I think I maybe should have entitled it Module 7, but because we're going. Also, I just want to say, I've been trying to make sure I've got some Easter memes going down, and in honor of the new Godzilla movie, you know, it just seemed like Godzilla versus the Marshmallow Peeps. I don't know, there was something weirdly satisfying about that. Because those, you know, what's more toxic, Godzilla or the Marshmallow Peeps? I think there's a case to be made, you know. So we're going for it. And then the other thing I tried to do was you know, started coloring to manage my stress. I kind of feel like there's a point where we pivot at this point to writing programs. By we, I mean you. You know, that sometimes you're like, ugh, you know, it can just be, Junlin, no, the peeps, no, I'm sorry, Junlin, you're wrong. You're just wrong on this one. I'm sorry. Well, actually, it turns out, objectively speaking, you're correct because it's an assertion of what you love. I actually have no objective rebuttal to that other than an emphatic disagreement with the principle of the idea. But in any case, okay, are we ready? I got 11:34. So let's start by 11:54. We're going to be done with module 5, 6, chapter 5, module 6. Okay, ready? I think I can. There are, by the way, we're on slide 103. There are only 113 slides. Yes. However, one of them, the next one, is kind of ugly. There's a couple that are ugly, but ugly. So that might slow us down just a little bit. But what I want to point out to you is that we just finished that. Okay. Remember, we were going through the control instructions and we did the conditional branch. And what we wanted to do here was kind of bring these things together and do an example, actually 2 examples, okay? So this is the setup. We're just picking something. Remember before it was like, Dr. K, why are you doing all the madness? And I was like, I don't know, just because we want to show you some, you know what I'm saying? And what we want to do now is give you something that's a little more, that was more just like, see those things in their own little ways. What are they doing? This one tries to just bring that together. So the idea here is that there are 12 consecutive locations in memory, and we just know that there's 12. Right. How do we know? Social contract. It's just, that's our program. We know there's 12. We're going to go 12 times. And we're going to say that the addresses of those locations in memory are from 3100 to 310B. Again, how do we know? That's just our program. That's where we put them. That's where they are. Don't care. And we're just going to sum it all up. That's it. Just sum up those 12 numbers. And by the way, we're ignoring overflow for now. For the sake of this program, to keep it just really simple, we're just assuming that the 12 numbers, if you add them all up, do not exceed, plus or minus 2 to the 15-ish, right? Remember, you got 2 to the 16th possible numbers. Half of those are positive, half of those are negative. So it's about 2 to the 15th positive numbers and about 2 to the 16th negative numbers, you know. So did I say 16? 2 to the 15, 2 to the 15. Okay. And what's 2 to the 15? It's a lot-ish. 2 to the 10 is a K. And 5, 2 to the 5th is 32. So that's 32K. Approximately 32,000 is the biggest number that we can represent, positive or negative, that amount. So we're going to add all these up. But for now, just assume that they fit, and we're not going to double check it. The first question is, can you do it without looping? That's your first little Trivial Pursuit question for the chat channel, or if anybody wants to jump on the audio. Could you do this without looping? Yes or no? Also, where the heck is everybody? I'm going to just do it like a survey, okay? Hang on a second. Okay, I did the little survey. Would you respond to that with a add reaction of either a yes or a no, Y or N? Okay, can you do that on that, please? Might just make it easier. We'll do a little survey. Can you do this operation, adding 12 consecutive memory locations? And so do the respond. You know what I'm talking about? Look at you see the little survey thing? There we go. There's a Y for yes. I'm going to add a reaction for a no just to make sure that everybody knows that that is an option that you can answer. If I can find the dadgum no. There we go. I'm going to add a no there. That one right there is me, but don't be deceived. I'm just putting it there to make sure that you know that there's that option. Overwhelmingly, we've got yes, you can do it without looping. And spoiler, because we don't have a ton of time. Yeah, that's correct. That's correct. Let me get rid of my, and we have a 100%, which was not one of the options. So let me, wait, how do I get rid of, I'm going to remove all reactions. I only want to remove my reaction. I don't know. I'm not sure what I do. If I say remove all reactions, will it get rid of all of them? I'm going to try it. No, I don't know. Okay, anyway. Yeah, you would just go, okay, you would hard code everything. There would be no looping. There would be no iteration. Okay. Would you want to generally do that? If you were writing this thing in Python, would you probably want to do it with a for loop? I would say, yeah, you really probably would want to do it with a for loop, right? But you don't have to. You can literally just go to 3100, grab the value, put it out, add it to some register, right? Clear some register out, add it in there, grab the next one, and just hard code the whole thing. It's just going to go, no, that's the sound it makes. And there's like no looping, no iteration, no branching, no control codes, nothing. You can do that. Ugly. There are weird situations in which that's actually the right thing to do, but usually it's automatically part of the compiler and not something you want to do code-wise. So, but that's not how we want to do it. We want to do this thing using iteration, using some kind of a looping structure, okay? So here's what we're going to do. This is all just kind of pseudocode, okay? We sometimes call this a flow chart, but we're going to take 3100, we're going to just stick that value into R1, okay? That's our starting spot. Then we're going to zero out R3 because R3 is going to be our running total. R3 is going to be the sum. R1 is going to be the location in memory. And R2 is going to be the countdown. Like, for 1 to 12 kind of thing. Well, what we're actually going to do is we're going to set it up to be 12, and we're going to count it down. And when it gets to 0, we're going to stop. Okay? Because we know it's 12 times. So here's what we do. We set R2 to be 12. So now we're set up, okay? So as we launch into this, the diamond always refers to, is that the diamond? Yeah. It always refers to a decision point. Is R2 0? If it is, we're done. Yes just goes jump around, kick out. But if it's not, then here's what we're going to do. We're going to go out to memory pointed to by R1. Whatever R1 points to in memory, we're going to go out there, we're going to get that value, we're going to put it in R4. Okay? Then we're going to take whatever's in R3, which we started by zeroing it. So whatever's in R3, we're going to take R4, add it to it, put it back into R3. So R3 is just a running total, a running sum. Okay? Then we're going to increment R1, which is going to make R1 now say 3101. It's pointing to the next spot in memory. And then we're going to decrement R2. So it was 12, now it's 11. And then we're going to jump back up to here where we're going to check to see if R2 is 0 yet. No, it's 11. Do it again, it's 10. Do it again, 9. Again, 8. Again, 7. Da, 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 da. Again, 1. And then when we decrement it 0, boom, we just did it 12 times, we kick out. Everybody cool with that? That's the algorithm. That's kind of how we're going to do this thing. And when you're working with assembly language, you have to kind of think of it at this level. Unfortunately, you really do have to think of it at this level of granularity, this fine. Okay. So stop me if you got questions, because Walter's not here, had family things that had to be taken care of. So I got nobody to nudge me along. I don't think Zach is here. So nobody's here to nudge me. And I always just want to slow down because I want to make sure you're getting it. That kind of slows us down overall. And I understand it's a bit of a dilemma. But we're going to now break this thing out, and we're going to do this in assembly language. Sorry, machine language. Are you ready? Yes, you are. Take out your relaxing coloring thing and just color it with one crayon, okay? Here we go. This is the machine language right there. And I'm going to go through this fairly quickly, but you've got to go to really get this. You got to go back and review this as well yourself. Treat this like an exercise that you're going to run on your own, and the homework is going to guide you as well. But okay, oh dear, it's too early to have the yawns already. Let me grab. Hang on. I'm just going to grab the cheat sheet and throw it up there so we can look on together. All right, let me throw this over here, and then scrolly. There we go. Okay, I'm going to try to see if I can maybe elongate it and skinify it. I don't even know if that's a word. I don't think it is. And scoochy it over a little bit. I don't know. Is that brutal to read? It's got to be bad to read. I'll just flip back and forth. Okay. But first instruction, 1110. Let's go looking for it. Load effective address. See it? Load effective address has a PC offset 9 and a destination register. Now, keep in mind that if we're running this instruction, we're not animating this one, okay? If we're running this, executing this line, we have fetched it, we increment the program counter. So the program counter has to be right now 3001. That's the program counter. right now, okay? Because we already fetched this, and while we're decoding it, the program counter gets incremented. And then we're going to take this number, which is a positive number. Is it not? Yes, it is. And we're basically, so we're going to look at this thing, okay? It's going to be FF. Okay, now, you should be able to do this in your head at this point. 3001 plus FF. What is it? This is hex. These are 2 hex numbers. Let me put it another way. Maybe simplify this. FF plus 1. What is it in hex? FF plus 1. Nope. Oh, yeah, Matt, 3100 for the first one. Yeah, it's 100. FF plus 1 in hex is 100. Therefore, 3001 plus FF is going to give you 3100. That was the address of the first location. So we're taking that number and we do the PC offset and we add that value to the PC. We get 3100. We put that value into the destination register, which is register 1. Boom. We just did the first thing. Put 3100 into R1. Next thing. Okay, 0101, let's just cheat. We already know this one. It's an AND. Register 3. So we're going to start with register 3. We're going to AND it with 0, which is going to go blow everything up, make everything a 0. Put that into register 3. What did we just do? We just zeroed out register 3. Now we got to get a 12 into register 2. How are we going to do that? Well, we're going to start by zeroing out register 2. There's register 2, and it was 0, blows it up, stick it back into register 2. Now register 2 has a 0 in it. Now we need 12. We're going to add, take register 2, we're going to add the literal value decimal 12, which is 01100 in binary, but that's an 8 and a 4, that's 12. So we add that to R2, we stick the result into R2. Now we've got that whole, we've done all the initialization. So 3 lines of conceptual pseudocode and 4 actual machine instructions to do it. Next up, branch. All zeros was a branch, okay? Remember, there's all zeros right there. There's the branch instruction. Now remember, we're going to branch to a PC offset based upon N, Z, and P. So what are we doing here? Here's the branch. We take 101. Now, remember again that 3004 is the address of the instruction that we've decoded. Before we execute it, the program counter got incremented. Program counter says 3005 at this point. We're going to add the value 5 to it, which is going to be 300A, which is, by the way, the line right below the graphic, right? It's the next line after 3009. The next instruction is 300A. In other words, and then we're going to go NZP. We're going to say, don't worry about the N bit. Don't worry about the P bit. If the Z bit is on, then branch to down here. Skip. If the Z bit is on, skip down here. How does the Z bit get on? Well, it's going to get on right down here when the last thing we do is we're going to decrement R2 when it goes to 0. But there's one kind of critical danger. Do you see it? If we had done some instruction like R3 gets 0 just before this branch instruction, what would happen? The Z bit would have been set, and this guy would kick out and your code would never run. So it's logically set up for what comes at the end of the loop, but it also tests right out of the chute. So you got to make sure when you go into this first conditional test that the Z bit can't be on. So it would not be smart to do R3 gets 0 as the first thing, or this branch on 0 would always be taken and you would never loop. Tricksy. A little tricky. Okay. The PC offset of the PC offset 9 is not a PC offset of 9. Okay, Braden? It is called a PC offset 9. It is 9 bits that is treated as if it were 2's complement notation, and it is added to the incremented program counter. When you see that, that's what it's doing. In the case of the branch instruction, it's telling you if the condition codes are actually set, the ones I say to look at, then I want you to take the branch where? To PC offset, incremented PC offset, plus this number, which happens to be right down there at the bottom. Okay? So, Josh, yeah, does that make sense, Braden? And on Josh, you lost me on why we can't zero out R3. We did it, but if we did R2 first, right, then did the RZ get 0, what are the control codes at that point? Well, I just put a 0 into R3, so the Z bit is set. Then I do a branch on 0. I say, check the Z bit. Yep, it's set, and I would take the branch every time. And I would never do the iteration. I would never loop. I would skip out of it because I did something just before that that set the Z bit in the control code registers. Does that make sense, Josh? So you got to do it, but you can't do it like right. That's one of the tricky things to just remember. Whenever you see a branch, it is the last value written to a register is what sets the control codes. That's what does it. So for example, if you jump away somewhere, like if you set some stuff up and then you jump away somewhere, do some stuff and then come back and you've trashed the control codes and then you check on the branch, you're going to have random results. It'll be random bugs. It's 11:54. I lose. Walter's not here, but I lose. It's okay. It's okay. Because this is the next step. This is where you're pivoting to writing your own programs, starting with stuff like this. Understand the logic of what you're doing and then convert it into something like this. That's what you have to do. Okay? I didn't make you build circuits. You do have to do this. Okay. I got a 12. The last value written to a register was 12. So the Z bit is not set. So it says, don't worry about N, check the Z bit. Right? Well, it turns out the P bit is what's set. And we don't care about that, and we only care about the Z bit. All right, next up is 0110. Let's go look. 0110. Wait, did I read that correctly? Yeah, 0110. Where is it? Scanny, LDR. The little OCR is off, but yeah, 0110 is LDR. Okay, what LDR does, if you recall, is you have a base register, you have an offset, you take the offset, you add it to the base register, and that's where you go looking to grab whatever's there, to pull it out, and to put it into the destination register. That's the social contract of LDR. So I take a base register, which is 1. What does 1 have in it? Okay, remember, we put the address into R1. And right there is where you see we did it. The address got put into R1. So we take the contents of R1, which is 3100. We add nothing to it. So that means we go out to memory at location 3100. What's out there? The first of the 12 integers. That's what's out there. We pull it in and we stick that into R4, which is just what we said we were going to do right there. So we did the branch. We checked on the branch. We said, nope, not done yet. Go out to memory at the location pointed to by R1, stick it in R4. Now we're going to do an add. You remember 0001. I'm going to take two source registers. Bit 5 is 0. Register 3 and register 4. That's in the pseudocode. I'm going to add them together, and I'm going to put the result into register 3. So register 3 has been incremented by whatever was in register 4, which is just what we said to do. Now we're going to increment R1 and we're going to decrement R2. Increment R1, easy peasy. Take R1, add the value 1 to it, put it back into R1. Now R1 says go to 3101 next time. And now we got to decrement R2 because that's our countdown from 12 down to 0. Again, an add, take R2, that's -1. See it? It's -1. Add that to R2, put it back in R2. Okay? And then the next thing you've done, the very next thing you have to do is, check it out right here. After you've done all these things, you got a hard jump. You got a solid, unconditional jump back up to that branch instruction to see if R2 is down to 0 next, yet. Okay? So I go, there's my branch instruction, all zeros. And what do? 1, 1, 1. What's the trick? I'm saying, hey, if any of the control bits are set, if any of them are set, I want to take this branch. Okay, are any of the control bits set? Yeah, always, 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 always. One and only one control bit is set. One of the 3 is on, the other 2 are off, always. So if I say 1, 1, 1, I'm basically saying unconditional jump. The only thing I have to piddle with then is where am I going? So that's a negative number. The program counter is currently 300A is what the program counter is. It's right there because it's already been incremented. Let's do this one in our heads. We got this value. What is that? We know it's negative, but what negative number is it? Well, if we flipped all the bits, we got 0, 0, 0. We go 1, 0, 1. We add 1 to that. Flip all the bits and add 1. And that gives us 1, 1, 0, which is, that tells us that's -6. We know it's negative. We flip all the bits and add 1 to find out what the magnitude is. -6. 300A. A is decimal 10. 10 minus 6, quattro. And so therefore, we're going to jump back to 3004, which is right there. What is it? It's that conditional branch. And that, my friends, is this right here in machine code. Whew! That was 8 pseudocode instructions here, just out of curiosity. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it was 8 pseudocode instructions and 10 machine language instructions to do that. Okay? Now, this is really, really important. It is not good enough for you to look at this. It's a first step, but it's not your ultimate destiny. Okay? It is not the ultimate showdown of ultimate destiny. You have to be able to think about some of these problems and do this at kind of a pseudocode level, and then convert it and do this. That is the next skill you have to acquire. Okay? Now, I don't know whether you're Godzilla or one of the peeps at this point. I wish that you are Godzilla, okay, or that you will soon be, the one eating the peeps instead of being eaten. It's a little bit intimidating, but the only way to do this is to just start doing it. You have to labor through it to get it. Your brain will figure it out, okay? So long as Batman doesn't burst from the shade. Okay, is that a reference that I'm not getting? That's not Lego Batman, is it? Because I have to admit that I've never seen that. And I'm really embarrassed by that, but I did see the original Lego movie. Oh, Lemon Demon. I definitely don't know that. Okay. So enlightenment would be great. Okay. This is one that if you, because I got to move on, if this is something that you're like, my head just explode, you gotta, number one, just go back to these slides. They're on Canvas and they're on YouTube. Screenshot it if you have to, but they're on Canvas as well. Look at this. Think about the problem. Look at this. See how that works. Go over here, walk through each one, look it up. You have got to acquire that fluency, and it's not enough to just go wanna, read, move on, and think you got it. Okay? You have to acquire the fluency. All right? So I'm not gonna go any deeper here just because we really do have to move on. But Walter and whatever that other guy's name is, Zach. I almost said Josh in a tribute to Josh in his earlier question. No, Walter and Zach are available. I will conceptually be available. I'm getting, again, it's all governed by how long I can sit in a bloody chair. But it's better and better every single day. And so we can walk through it with you. And we're at a point where we can even start to do some help sections for anybody that wants to really like tease these things apart. But you got to first try it yourself and labor through it. Then we can do some help section. Okay? Deal? Hey, I got to go. I mean, I don't got to go. We got to go. Okay, there are two. Now, we've done iteration where we count down, right? A counter. But there's actually another way, right? With a counter, you actually have to know how many iterations before you set the thing up, right? You have to know how many iterations there are going to be. But what if you really don't know and you're just going to go until you get to a certain thing? So, for example, we call this thing a sentinel. Don't worry about the word sentinel. I'm not going to throw the word at you like on, an exam. But I just want you to understand that there's, broadly speaking, two ways. One is I know the number, I know how many, classic for loop. The sentinel is more like a while loop where you're just like, hey, pull a value out. I'm looking for -1. Until I get to a -1, I'm going to keep going. Is this a -1? No. Okay, I'll add it. Oh, is that one a -1? No, I'll add it in. How about that one? No. Keep going. Eventually it's like, oh, -1. I'll stop. That idea. Okay? That's the idea. The same thing happens, by the way, in strings. Most languages, when it comes to representing strings, so I dropped my light. When it comes to representing strings, actually does it with a null termination. It just means that there's a bunch of ASCII values, and then at the end there's the literal value 0, and we sometimes call it a null termination. Okay, meaning that the string is whatever it is until I see a 0, and I mean the actual number 0 in memory, like all zeros. When I see that, then I stop. Okay. All right. Where am I? So here's just a little bit of a difference, and I'm only going to just point out the differences here to you. We set it up kind of the same way, right? I'm basically saying, okay, it's the same integer addition, but I'm going to say that the list is terminated by a -1. I don't know how many there are. I'm just going to go pull the value, but before I add it, I check it. Is this a -1? If it is, I'm done. If it's not, I'll add it, and I'll just keep going. And then we talked about null terminated strings. Okay. So R1 gets the address again. R3 gets cleared because that's the summary. But notice there's no R2. There's no R2 set to be 12 and counting down. That one's gone. Check it out. Right? No R2 because we're not doing that this time. We're doing it differently. And then I start by pulling the first value out of memory pointed to by R1 and putting that in R4. So in other words, before I add R4 to R3, I check it. okay? Then I basically go, is R4 the sentinel? Is R4 the thing the thing that tells us we're done? In other words, is R4 -1 in this case? If it is, we're done, we kick out. If it's not, then we do really kind of what we did before. We add R4 into R3, put that away. We increment R1 because we got to keep moving through memory. Only now, instead of decrementing the pointer, the counter like we did last time, we just grab the next value out of memory. And then we check, and then when we get to the loop, we're like, check that to see if it's the sentinel. Okay, oops. Everybody got that? Here's the code again. And you got to go hit this on your own. You got to hit this on your own. I beg you. I beg you. Hubert also begs you. You cannot deny the cuteness. Plaid monkeys? Are you kidding me? You have to do it. Okay, let's check it out. These are the things that are, I'm going to kind of try to gloss over the stuff we already hit. Like, for example, getting that value into R1, we already did that. Clearing R3, we did that. Now we're going to go out to R4, pull the value that's pointed to by we're going to go out to memory pointed to by R1 and put it into R4. We did that before, but the logic was a little different. Then what I'm going to do now, check this out. What's going on right here? I'm going to branch on negative to 3008. What's going on? Somebody's got to answer this one. I'm branching on negative. So I go out to memory, I grab whatever R1 points to, I go to that spot, I pull what's there, I pull it out, I put it in R4, and now I branch on negative. What's the logic? What's going on? Talk to me. I'm going to wait. And keep waiting. Excellent answer, Matthew. Question mark. No, come on. What does branch on negative do? What's it do? What's the social contract of that instruction? Okay. It checks the control codes right there. And which control code or codes is it willing to look at? Well, it says look at the N bit. Don't worry about Z. Don't worry about P. Okay. Well, yeah, it takes the jump. So what Matt said, it goes to 3008 when 4 is negative. Let me make that more explicit and more clear, because what you've written is ambiguous and not clear and a little bit confusing if you don't already know the answer. It takes the jump. It takes the branch, meaning it causes the value 3008 to be put into the program counter so that becomes the next instruction, okay? And it does this when the value I pulled out of memory and placed in R4 was a negative value. Now, what that's really doing is not really checking for -1, but we're kind of assuming really any negative number is going to work as a sentinel. If it's negative, we're going to kick out. Okay. And our presumption is that we're adding positive integers. Okay. But that's the gist of it. Does that make sense as well, Matthew? I'm trying to encourage you all to be precise with your language and expressing so that there's not a fuzziness in your understanding. Plus, some people are going, when 4 is negative, 4 isn't negative, it's positive. It's positive 4. When you mean R4 or register 4, okay? And then we're basically doing exactly what was over here. But this is the point. We can check to see if the value we pulled out is the sentinel with this branch on negative. Because the sentinel will be a negative number, and we're only dealing with positive numbers. When we see a negative number, we're done. So every time I pull a value out of memory, I check. Is it negative? Oh, it is. We're done. It's not. Add it, grab the next one, and check that one. Add it, grab the next one, check it. add it, grab the next one, check it. When it becomes negative, we kick out. As long as it stays positive, we keep churning and burning. Okay? That's it. That's it. So we can use sentinels, we can use counters. They are both used in computer science, okay? In high-level programming. We can do both of these in Python, right? We usually think of the counter as like a for loop. Usually think of the sentinel as kind of like a while loop, like grab a number while that number is not negative, keep going, you know, that kind of thing. For loop usually, again, depends on the language, depends on the high-level language. But usually it's like, hey, do this like 10 times, or, you know. Okay. And then the only thing we really haven't hit with control instructions is jump. Jump is a hardcore, unconditional jump anywhere. That GIF is, sorry, just looking at the GIF here. It's just, I don't know. I don't know. Is there something happening behind this guy? Like, is there something coming out of the woods? I don't know. It's just creeping me for some reason. I don't know why. Sorry. It's just, I haven't seen that one before, and it's bugging me just a little bit. I just feel like he's in danger. That's all I'm saying. I just feel like, dude, oh, is there a vid? I don't know the vid. Obviously, I don't know the reference. Okay. Here's the deal. I'll check the video in a sec once somebody drops it. When we do the branch instruction, we're plus or minus, what is it anyway? The branch instruction is, yeah, it's plus or minus PCI. It's PCI offset 9, right? So it's plus or minus. And sorry, I have to now do this thing.
Photo. No. Hi. Okay.
It's not helping any. It's not. I just watched it. It's not helping. Okay. The jump instruction, not limited. It goes to whatever you say the base register is. It takes that value and it loads it into the program counter. Boom. You just teleported. That's it. That's what the jump instruction does. Okay. That's it. The only trick is you got to get that address into the base register. Okay. You got to get the address into the base register, after which you can teleport anywhere in the entire system. Okay. All right. Now there's one other thing, and we're going to barely talk about it, which is the trap instruction, which is basically a variant of the jump subroutine. Okay, it's like a jump to a subroutine, but it operates a little differently. And we're going to deal with this in module 10. Okay, so let's not worry about it too much right now. But just understand that there are these trap vectors which you can use to do certain functions, like get a character from the keyboard, output a string, you know, and stop the computer, stop your program, stop everything from running, which is the halt instruction. Again, we will break this down in more detail later, okay? And then this one would be, Kevin, thank you. Thank you for Kevin. Okay. All I'm going to do here, and we're going to be done, is look at the an example of like where we're going to input a character from the keyboard, and then just you tell me a character, then I'm going to go look in a file, and I'm just going to just check and see how many times that character occurs in the file. So another, not a weird thing to do in a programming environment, and then just spit it out, okay? And all I want to show you, is that go to the end? Yeah. I just want to show you, and this one's much more grungy, And we're going to just kind of like tease you a little bit with this because we're going to break this down in more detail, okay, coming up. But it's just an example of saying something that simple like give me a character, go out to some spot in memory, and count how many times that character occurs and kick that out. That's not crazy complex, and this is what it kind of turns into from a logical perspective when you deal with an entire program. And I'm only going to just go crazy quick. Set a count, initialize the pointer, give me a character from the keyboard, give me a character out of the file. Are they, are they the same? If they are, if I'm at the end of a file, stop. Otherwise, are the characters the same? If they are, increment my count. If they're not, kick out, grab the next one, go again until I'm done, spit out my output, and stop. But this is what that looks like from a kind of a pseudocode design sort of perspective, okay? There's a reason that I did the coloring thing. I just think this is the point where some of you gonna get a little bit, a little bit of, I don't know, man, a little white knuckle, a little sphincter time. This is a point where you have to lean in. You got to lean forward in the skis. Okay, you got to lean into this a little bit because you've got to look. If you're all pretty new in the program. You're gonna be CS majors. You want to be programmers. You want to be developers. There is this critical ethic of coming across this new thing, and it's like a little intimidating and a little difficult, where you've got to go, okay, that this is on me. I mean, I can try to teach you as well as I can teach it, explain it as well as I can explain it. There's a point where you just have to lean into that with your own brain, your own time, making a little extra time to make sense of it. Okay, to make your sense of it and to get it to where it starts to click. That ethic is going to just drive you for the rest of your time in this program, in this undergrad program, but also for the rest of your career. You can't just be like, oh crap, let me go check this out on a cheat site, or let me go check this out on, whatever. Let me go to Stack Overflow and see if somebody knows. This is stuff that you've got to have in your fluency, in your toolkit. There are other things you can go look up on Stack Overflow, like if somebody's got some cool code for this machine learning thing that the point is not to write the code. The point is to understand more kind of algorithmically. This kind of stuff, it's very foundational, and you got to get it inside your own head, okay? Have to, have to, have to. So that is this is the bump. This is the bump for the next month where this is what you got to do as we pivot from machine code to a little bit more understanding about programming and then assembly language, which is going to be like a way easier form of machine language. Okay? But you'll understand what's going on underneath the whole way. Okay? Oh, yeah. Okay, so we did finish. From 34 to 20 is 26, 46 minutes. Yeah, I doubled up. I didn't make it, but hey, it's okay because that's the end of module 6. End of module 6. Okay, now this next module is basically it's really just an interlude. Okay, chapter 6, it's kind of module 7 in a sense. Okay. And this is kind of it's really kind of a critical juncture. Let me see. I still don't understand the okay. I don't understand it.
Photo. No. Hi. Okay.
I don't get it. I don't get it. I really don't get it. Are they with him? I don't get it. Sorry.
It's meant to be like a really hesitant, like, okay, I guess I get it.
Okay. And I,
Yeah,
of
because
course,
the girl, she's like hi, and then he just says okay. So he obviously like doesn't understand what she's
Photo.
saying.
No. Hi. Okay.
that's kind of,
Layers of meaning.
it's layers of meaning. It's growing on me. It's growing on me just a little bit. Yeah, it's growing on me. Uh, I'll have to check with my 30-something son who's a meme lord and see if he can further enlighten me concerning this particular meme or its origin or history. But I can see the nuance. Okay. Now, here's the thing. Let's go. We're on the next module. What I really want to talk about right now in this next module, and we will, by the way, today's Thursday, right? We're going to finish this module no later than Tuesday. You have my word. I did swear that we would be done. I probably swore that we would be done in 20 minutes too. I was wrong, apparently. Okay, this is one that is less technical and more kind of coaching. You know what I mean? It's a little bit, it's really what I was just kind of saying, which is part of the inspiration. As a programmer, as a developer, as a software engineer, as a computer science major, as a computer scientist, as a data scientist, I don't care what, you're going to encounter stuff for the rest of your career that you have no friggin' idea what it is the first time you see it. It's this is what this is what the field of software is made out of. Okay, it's not about here are the well-known questions with their well-known answers, and then you're going to run around, for the rest of your career, and someone's going to go, "What's the opcode for the add instruction?" You're going to go, "Thank you, Dr. K. 0001. Give that boy a raise." Okay, no, this is not how it works. All these foundational things that we're kind of going through, they just nestle in the toolbox. You know, that's just like how you swing a hammer or how you work a screwdriver. They're your tools. You're going to go in there and they're going to say, "We've got this file. It's data. We don't know what it is. We don't know where it came from. We do believe that it contains this, but we're not 100% sure. The people who built it no longer work for the company. There is no documentation. And all we have is this binary file. Can you divine what it is?" That I've had that happen on more than one occasion. It's a random thing. It's not like every day. I'm just saying, can you understand how to make a thing work when um, when the documentation's wrong, when the thing doesn't work right, when you go to do a thing, you know, and you don't know what to do. Can you figure it out? Can you find out if nobody is sitting next to you telling you what the answer is? And by the way, and this is critical, and the way I set up 2810 is so that, basically cheat sites like Chegg and whatever, honestly, if you're getting your way through this major with Chegg, then A, shame on you. B, quit the effing major. Seriously. If this is, I'm going a little pissy right now. Seriously though, you've got to, it's A, even if you manage to get through the major and get your degree, you're going to suck. You're going to just suck. And you're going to be found out that you suck. It's not going to benefit you, you know? And it's gonna diminish the degree for everybody else who's rocking, and repping the V. It's just gonna diminish the brand for everybody else, right? I'm really serious about that one. I'm really passionate, if you can't tell. Seriously, if you're cheating your way through by hitting cheat sites, then quit the effing major. That's what Dr. K says. I'm really serious about that. Or stop it. Stop it. Pony up and figure out how to do this thing. The way that I set the class up is the homework isn't worth anything point wise, so there's no intrinsic motivation to cheat on it. Okay? First time I taught this class and the homework had value, 60% of the class across 2 sections cheated on the homework when there were points at stake on the homework. Okay? Well, and I realized A, that kind of pisses me off. B, you're just hurting yourself. C, uh, everybody then just crashed and burned when it came exam time. So, you know what I mean? I'd have like homework from a student that's like just smoking this beautiful program. The very same program is on the exam. It's very obvious that he can't find his butt with both hands when it comes to this problem. But the homework's beautiful, and the exam is like no, zero clue, not clue, right? That's a big reveal right there, okay? Anyway, it's really important to me, you know, that if you're going to be in the major and you're going to stay in the major and you're going to succeed and you're going to rep the V, and you're going to walk out and augment the brand of UVU, which we've got a great program, and it gets constantly better, both because of what we're trying to do as faculty, but also because of what you're doing as students. Okay, I feel like the students are just getting better and better. Um, don't know why that is, but it feels like it. So, you know, you got to own it. Okay, I, this is me beating a drum. Okay. Um, Yeah, by cheating, I just mean copying crap on the internet. That is what I mean, Braden. Um, uh, yeah, Michael says stop it. Um, yeah, because right, because it's cheating. Okay, let me back up. As long as we're talking about cheating and plagiarizing is essentially my sort of back of the napkin definition. It is passing off something as your own work when it is not. It's misrepresentation. So when I hand in something and it's my homework under my name, but I got it from this other place, then I'm lying because I'm representing that was my work, but it wasn't my work. It was somebody else's work. Okay, that's the problem from just a pure honesty perspective. But from a sort of internal consequence perspective, the problem is that you, as Matt said, you're not internalizing anything, right? If you're going to study French, which I did, in college, you're going to study French. There's a presumption that when you finish your French degree, you can speak French. You know, if you can't speak French, it's a little rough. If you're just like, first of all, language programs are set up so that you really can't get through without, because you've got to converse, you go to, you know what I mean? You go to language class and usually right out of the chute, that's the language of the class and you can't speak English, right? At an American university, for example, you would have to drop in and speak whatever the language was of the class. You know what I'm trying to say? So this is actually one where it's a little easier to kind of skate through, but there is at some point a point of reckoning. That's all I'm saying. I've seen it happen at the 4,000 level, where somebody rolls in and it's obvious that they have basically cheated their way through. Now they've wasted 3 years of their own time and maybe their parents' money, you know, to get to a point where you're not going to get out. You're not going to finish. You're not going to get that compiler done. You're not going to get, there's some classes down the stretch you are not going to pass if you don't actually have it inside of you. So you got to start now. Okay. I hope that's not too much of a wham wham. Get off my lawn. You know what I mean? I'm not trying to be. I'm not trying to get off my lawn. I'm saying this is the pivot point where we lose a certain cross section of students because you have to start writing programs in machine language and you have to start writing programs in assembly language. So after all that background we've done, it's time to start writing programs. Okay? And that's unusual for a CS class. Usually you start right out of the chute writing programs. We start out right out of the chute talking about electricity and light bulbs and crap. So yeah, Texas said, try to understand the problem and use notes, resources from the book, internet as the last result. Try to understand the problem to solve it right. And at the end of the day, just understand that this is one example, and I swear I'm gonna get off this. I have this amazing book of chess puzzles. I feel like I suck as a chess player. I want to get better. And my son, the meme lord, is, a actually pretty highly rated chess player. Okay. And real deal and a chess teacher, etc. Okay, but I've got this crazy thick book by what's the guy's name? Laszlo Polgar, and it's like 3,000-4,000 chess puzzles. Now the answers to all the chess puzzles are in the back, and there's 6 puzzles per page. I'm right now doing. I did all the white to move mate in 1. You've got 1 move and there's a checkmate. I'm now on white to move mate in 2, meaning white's going to move, black's going to move, and then there's a checkmate. Okay. Well, these get a little complex sometimes. And what I do, I have a board set up, and when I'm on to the next puzzle, I set the board up because I like to see the pieces on the board, live. Okay. Now, imagine that every time you saw a puzzle, now, mate in 1, a lot of times you could solve it in like 2 seconds. You'd see it immediately. Mate in 2, you got to noodle a little bit. Like, okay, what could I do? What's available to me? What are the dynamics? I've got to study it a little bit. And then what I do is when I think I've got it solved, then I look in the back to just double check because I've had times where it's like, got it, whoo, mic drop. And then when I look in the back and I'm like, wait, that's not what I did. Then I look at what I did. I'm like, oh, hung my queen. Okay, that was dumb. Didn't see that. You make a dumb mistake, and I want to know if I got it right. But if I look first, I can never unsee that that's the correct first move. And then mate in 2s just become mate in 1 because they only give you the first move. It's like, okay, well, I already know, it changes the entire cognitive experience. And if you did that entire puzzle book, looking them up, what are you doing? Just double checking that the answer was right? You see what I'm trying to say? It's very different than when you're staring at a blank board with nothing but your brain and just going, okay, what do I do? Well, I could do this, I could do that, I could try this. What about that? What about this? I've got all this processing I've got to go through. Then I've got to try it, check it, and go, I think I'm right. I think that's it. Is it really? And you see, there's this elaborate process I've got to go through. But by subjecting myself to this process, I actually become a better chess player. I force myself, just like forcing myself to speak French, which I do speak, and forcing myself to speak Italian, which I do speak, and Spanish badly, but enthusiastically, forcing myself to speak. It exercises different circuits in your head than simply reading and going, oh, I get it. Oh, I get it. That is not the same as blank piece of paper, produce it yourself. Okay? Somebody says something in Spanish, if that's your second language, for me it's my 4th language. But you know what I mean? And then you're like, no, I know what they said. Woo! Okay, now back to the same scenario. They said something to you. You produce that thing they just said in Spanish from scratch, no help. Stand there, stare at them. You understand that's 100 times harder than understanding it after they said it. 10 times harder at least. That's what this is. It's fluency. It's language. Okay, am I good? Do you do you understand? Okay, I think I've made my point. I hope you understand how emphatically Perfektenschlag. Yeah, no, it's something. There are more possible chess games, Texas, um, than I think like atoms in the known universe, something like that. It's absurd complexity. Matt, I am spitting facts. Thank you. I'm done spitting my facts. But really, you got to do it. You got to pony up. And if you're struggling, that's what we are here for. Okay, Zach, Walter, and I are here for that, helping you. Um, And if you don't understand it, man, just come talk to us. If you suck, just say, I think I suck. Okay, great, because everybody sucks at first. Everybody sucks when they start. Quote me on that. Everybody sucks when they start at whatever. Okay. How's our time? Are we out of time yet? We ought to be. It just feels like I just feel like one of those classic coach speeches. If we played them 10 times, we might lose all 10 times, but not tonight. Okay, let's go. Problem solving. Okay, this is less about cheating, but it's now going really kind of on that same thing. That was all preamble. Not everybody's great at this, but if you're going to be in this major and you're going to have this career, it's time to start getting good at it. If you're not good at it, you got to get good at it. This is just one of the things, okay? And there's a reason that engineers are good at fixing stuff even when it's not in their field of study, right? Because there are skills about teasing stuff apart, figuring out how they work. You know, I've done, I think some of you have, who are maybe more of the natural engineers, where you've gone into something, right? I once, when I was 28, the water pump on my station wagon, because I had a bunch of little humans at the time. Well, I mean, I had three. That's plenty. And I was a new engineer at HP in the Bay Area, and it was like a freaking $600 or $800 repair job, and I was broke, and that was the only car we had, and it was tough. So what do? I go get a Chilton's manual, which was the manual that you can get for cars that breaks down and this is 1988, by the way. There's no interwebs, okay? Um, we're a solid, 6, 7 years before the interwebs become a known thing. And so I get a Chilton's manual. I go down to a store. How archaic, how quaint. I buy a Chilton's manual so I can sort of just see how the thing. It doesn't tell you what to do. It just gives you like big schematics of how all the parts go together. And I got my tools. I just dive into this. Texas, you know what I'm talking about. Um, Let me see. So the docs are wrong. Yeah, Matt, get over it. The docs are always wrong. So Bray, my grandpa always told me you got to suck a lot to suck a little bit less. Yes, exactly. It's kind of like get over. It really is like you're gonna suck. Get over it. It's okay. You ever try to play both parts of the piano when you first try to do that? You're like, duh, and you can't believe your brain's ever gonna figure that out. Anyway, so I'm 28. What do? I don't have the money, and I got the station wagon, and I got the family. So I dive in. I just start taking stuff off out of the engine. I label it with tape, like number it. I start spreading it around my garage. I spread it on the ground around the garage, all the way around. It takes me about 8 hours to tear the whole thing apart. And I literally am tearing the engine apart down to the water pump, which I think is actually just goes right into the block. I mean, I'm just pulling stuff off the front of this engine, not knowing if I'm completely toasting my entire car, with a high likelihood that I, in fact, am. Sorry, just dropped something. Um, and then get down to the part, and I buy the water pump, which was like $100. Get to that part, put the water pump in, attach it. I didn't have a torque wrench, so I wasn't 100% that the torque I was putting on it was correct. But then went in reverse order, slapped it all back together, and unfortunately, you can't do unit testing on it. You know what I mean? You can't do unit testing to make sure like that part's okay. You got to basically just put the whole thing back together and then get in it and turn the key. Watch the temperature gauge, and anyway, it worked. It worked. I succeeded. I saved myself like $500 or $600 when I was 28 in the 80s. It was a lot of money back then, you know. But I'm just saying, it's just an ethic. It's an ethic as much as anything that just says, you know what I mean? There's kind of a thing that sometimes happens, which is step zero. You cannot just throw up your hands. Okay? You cannot, ready? You cannot just throw up your hand. Okay? You can't do it. You can, but that's not being an engineer. Okay? You can't just stand there like you got a poopy diaper and you're waiting for someone to change you. You can't. Okay? There's an ethic to being a developer, a software programmer. All of the things you can do in this major, the ethic is you can't have that kind of helplessness. So it's like, yeah, I don't know a crap ton. Okay, join the party, by the way. I have a doctorate. It doesn't matter, right? I finished my PhD 23 years ago. How much of what I was studying back then do you think is like poignantly relevant right now? Okay. You get this? Do you get what I'm trying to say? Precious little of what I studied. How about my undergrad? Okay. Crap, man. My undergrad started, oh man, I'm gonna feel so old, but my undergrad started 40 years ago was when I started my undergrad, like in earnest. 39 years ago was when I, in earnest, started my undergrad degree and stopped going to college 23 years ago. This material is still relevant. Assembly language is still relevant. Binary is still relevant. Hex is still relevant. But I'm just saying there is way more that happened since I was in school than what I learned in school. I'm constantly dealing with crap that I never had a class on. In fact, one of the cool things when you're a professor, and especially when I had like my grad research program when I was at BYU, where there was a grad thing that was a different, part of the job than it is here. If there was a topic I didn't know anything about, I would just sign up to teach a class on it. You see the ethic? Well, how are you going to teach a class when you don't know anything about it? And you're like, well, I will when I'm done, won't I? Yes, you will. You know what I mean? It doesn't frickin' matter. But you can't just be throwing up your hands and saying, I don't even know where to start. Okay, you cannot do that and be a success. I don't even know where to start. Anyway, okay, Braden, that's fantastic. We're about out of time. The docs are always wrong. Okay, every doc, that's documentation. Okay, every documentation I think I've ever seen of any complexity whatsoever is not only incomplete, which is 100% of the time, but factually wrong. Like if you do exactly what the doc says, it's not going to work. What do you do? What do you do? Well, you figure out how the doc's wrong. You figure out what they should have said. You try a bunch of different things. You test it out. Well, what does it do? Well, that seems to be wrong. Until you figure out how to make it work, or you find a workaround, or that's what this major is about. It's not about learning answers and regurgitating those answers. It's about acquiring skill at the end of the day. Yeah, man. No, that, and so, yeah, let me see. Last things, just a couple comments and we're out of time. So Texas said this YouTuber stated that science is like learning how to break things down to the most basic level. Doesn't matter if you can put it back together as long as you can get the knowledge of how it all works. I like that a lot. And I was one of those kids who would tear things apart and never get them back together. You know, take a big thing and learn what the little things are. That's what we're doing with these algorithms. And when you go to build the thing, you're doing the exact opposite. Take little things, take a big sense of it, but then take little things to build that thing. It's stepwise. You got to take the big, how do you eat an elephant? One bite at a time, as the old things say. I can't imagine, but you know what I'm trying to say. Matthew said a professor said that if he didn't know the answer to a question, when he didn't know the answer, he'd get the students to split up into groups and then have them teach themselves. I like that. There's no shame in that. You think I know everything? Good gravy. My gosh, no. No, and then if I don't touch it for a year, it all goes away. It's a skill. It's a skill and it's an ethic. But okay, you with me? You got to be with me. To pivot to this next thing, to go to this promised land that we're going to, whatever, you gotta sign up for this next leg of the journey. And this is the last leg of this class, but this is sometimes people biff it right here. So I want you to go with me, stay with me, and let's do this next thing together. Zach is available, Walter's available, I'm available, and we will help you. Okay? I'm done. And we will come back and we will finish these slides, by the way, on Tuesday. I still insist that this will be true. Hang in there. Do it.